All right. So now we're actually going into Chapter 8, Section 4. Okay, so this is going to be your quadratic equations with a coefficient greater than 1. So you're going to see something like this. Okay, so you're still going to factor down. All right, and when you factor down, this time, yes, you have an x squared, but you have a 2. So what's my factors of 2? 1 and 2. Now, luckily, that coefficient only breaks down as to 1 and 2. He's prime. Okay? It's your problem when you get big composite numbers like 12 x squared. Well, you could have 1 and 12, you could have 2 and 6, you could have 3 and 4. Okay? And you could also switch it around the other way. Now, yes? Okay, right now, that does not make it a quadratic equation. A quadratic equation, it has to have the variable going to the second exponent. Okay? If it goes into a third, hopefully then there's an x on everything or the same variable. I can factor it out and then break it down as a quadratic. But right now, quadratics only have the power of 2. Okay? So we're going to be good there. Now, so yes, you were right. I'm going to break this down as to 2x times x. Alright? Then I'm going to break this down as to what? The only factors there is 1 and 3, right? Would you agree? Okay, now, and this is the way that we learn it, like a long time ago. I'm going to show you in a minute a trick, okay, or an easier approach to it, okay? Now, what's going to happen here is then you've got to decide, first of all, they're the same, and they're both add, so that's why I put an add in here for both. I know one of these has got to be a 1, the other's got to be a 3, or I could switch it around and say that's a 3 and that's a 1. And we have to decide. So you have to play around with it. Alright? So if I go, let's say we make this the top ones, 1 and 3. So if I do my outside terms, I get 2x times 3, which is 6. My inside terms is 1 times x, which is 1x. So when I add them, what is 6x plus 1x? 7x. I don't need a 7x, right? So that one doesn't work. But what happens when I flip it around and put the 3 in this spot and the 1 in that spot? 2x times 1 is 2x, and 3 times x is, so when I add 2x plus 3x, I get 5x, which is what I need. So that would be my original problem right here on the bottom. Now, that one wasn't so hard because they were both prime and I could do it. But could you imagine if you had a problem like 12x squared plus 17x plus 24? Oh my goodness, there's too many factors, okay? The trick I'm going to show you is going to help you solve problems like this that are a little bit more complicated than this one, okay? It'll also solve that one, okay? But that one we could figure out by just a trial and error of 1 or 2 steps. This one would be forever. Because could you imagine I'd have 1 and 12, 2 and 6, 3 and 4. And remember then I could switch them around. I'd be 12 and 1, 6 and 2, and 4 and 3. And over here I'd have the same thing. I'd have these things. So could you imagine having to do, let's see, there's 6 different ways these numbers could appear. And then there's 16 different ways or 8 this one could appear. So that would take you a long while. Alright? Yes. Alright? So now I'm going to show you a little trick of how we're going to factor a little bit easier. Okay? This is what they call a box method. Okay? Now, there's other teachers who show other things out there, and it's not that any is easier or harder. Okay? But I'm going to kind of show you this little box method, all right, for you to come up with. Now, we're going to look at the same one that we just originally started with, 2x squared plus 5x plus 3. Okay? Now, in that last table, if y'all remember that last table, okay, the step before, they ask us to multiply m times p and a times c, right? I'm only worried about this a times c. And if you remember, your quadratic equation was ax squared plus bx plus c. So my a is 2 and my c is 3. So when I go to the x, this time I'm going to use 6. I'm not going to only use 3. I did last time because I had a coefficient of 1. So when I multiplied 1 times the last number, gave us the last number. This time, Jackson, answer that phone, please. Just say Miss Woodley's room. It's probably you. Okay. Our homework is going to be page 496, 10 through 28, which you can do 11 through 27, the odd ones. Okay? I'll attach the video a little later, so if you're out, about, have access, whatever, you can pull the video up, okay? All right. Now, so everybody understands where the 6 came from, right? Okay, 6 came from 2 times 3. Okay? It's okay. Yes, multiply. Okay? So you'll multiply those. Alright? The bottom one is still going to be your middle term, which is 5. Oops. If I can write. Now, again, what numbers do I get there that add up to be this? 3 and 2, correct? Now, I can't just go straight into x plus 3 and x plus 2. I cannot do that because, you can go ahead and go through, that's fine. Okay, you cannot do that because my last term was not just a lone 6. I have a coefficient out front. So what this is telling me this time is, this 3 and 2, I'm going to break this down one step. So this is where your box method comes in. So I'm going to make my box. And it's going to have 4 squares. Is everybody good there? Now, in this first upper left square, you put your first term. So 2x squared goes here. And we're going to do several of these, so you'll get practice remembering where they come from. The last goes by itself in the bottom square. Because if you were reading like a book, this would be the first thing, and then this would be the last thing on your page. This is the first thing of your quadratic equation. This is the last. So it's going to stay first and last. It's the middle terms that are going to change. So you're going to take one of these, and you're going to put in one of those boxes. And you're going to take the second one, and you're going to put it in the second box. And I'm going to put my variable back with it for right now. Okay? So basically, if I was writing this out long ways, that would look like 2x squared plus 3x plus 2x plus 3. Okay? But I'm putting it in my box. Did everybody see where I got everything so far? Now, you're going to factor out between just these two top things right here. What do they share in common? X. So I'm going to pull out an X. I'm not worried about what they have left. I'm only going to figure out what they have in common. What does this bottom have in common? Do what? Okay, nothing would not be a 0. 1. Does everybody agree that they have at least a 1 in common? Because I can pull out a 1 and it doesn't change either number. So I'm good. I cannot pull out a 0. So when you say nothing, don't think of 0. Okay? Think of, okay, nothing tells me they're prime, so they both share a 1 in common. Okay? Go up and down. What do they share in common this way? 2x. What do they share in common here? Now, the number that's closest to that determines positive and negative. These both were positive up here, correct? So that made these both positive. Okay, the 2x and the 2x squared and 3 were positive, so that's why everything looks positive right now. Okay? Because this 2x squared is positive, both of these are positive because they're touching that block. This 3x was positive, so the 3 I factored out as positive. From this 2x, when I pull out, that's positive, so that's positive. So that means it's going to be x plus 1 and 2x plus 3. So my factors are 2x plus 3 and x plus 1. I'm going to try and slide that up. There we go. So those instruments aren't in the way. No, I could have had x plus 1 first, and I could have had 2x plus 3 as my last. Okay? Now, I could have even switched this 2x and 3x here. Okay? I could have put 2x here, and I could have put 3x here. And it's all that's going to do is change these things around a little bit. Okay? So it's really not going to matter. I can factor across, okay, or down, depending on where the numbers are, and you're still going to get the same thing. Okay? But this will be grouped together no matter which way I go. And then this will be grouped together no matter how I go. Okay? Let's look at another one. Let's say I have 5x squared plus 13x plus 6. First thing you need to do, and you may want to write this for a little while, a times c. So that means what? 5 times 6, correct? Which is 30. So now I'm going into my x, and I'm going to put 30 and 13. Does everybody remember where those come from? So, if I break them down, what are they going to be, Jackson? 10 and 3. They were positive, so these are both positive. So now, when I go to my box, what goes in the first squared? 5x squared. What goes in the last square? 6. Now what goes where? So 10x and 3x. Just don't forget that variable. Okay? Now, let's factor out. What's have in common? 5x. What we have in common? 3. If I can write my pen, I don't know where I'm at here. That would be a 3. I want to erase that so it looks better. 3. What is this? What's in common? 1x. And what's in common? 2. Just 2. Alright, was this positive or negative? Positive, so both of these are positive. Is this positive or negative? So that's positive. Is this positive or negative? Positive. So what's my two terms? X plus 2 and 5x plus 3. I could have also had 5x plus 3 times x plus 2. I could have had that as well. Yes, we're going to do one with a negative. Yes, Davey.
I'm a little confused on how we're going from the x to box.
Okay, all right. Do you understand, first of all, in my x, where 30 and 13 come from? Okay. Then you understand how I'll become 10 and 3? Okay, all right. Now, when I go to the box, your first left squared, your top left square is your first term, always. Okay? Your last box, which is your lower right, is always your last number. That's the constant. Okay? These two is where I'm getting this from. Okay? So 10, but I have to put the variable back with it, so that's 10x. And I'm taking my 3 and putting in the other box. I could have switched these around. It did not matter. I could have put 3x here and 10x there. It does not matter. Okay? The only thing it would have mattered was if this was a 3x, then my 5x plus 3 would have appeared on top. And if my 10x was here, my x plus 2 would have appeared on the side. But it would have worked out the same way. Okay? To get which numbers? These?
So 10x, and then you do 5x squared, and you get 5x.
So I'm going to factor this way and put whatever comes out that way. So if I'm going across, whatever they have in common comes right out to the side of it. If I'm going up and down, then it's just going to go right on top of it.
Like, you go over, and then over, then up, and over.
Right. Or you can do up and up and over and over. It doesn't matter which way. As long as I'm factoring out both my columns and I'm factoring out both my rows, it does not matter. Okay? You can do columns first and then rows last. It doesn't matter. Okay? All right, let's look at one with a negative. Okay? Let's say I have 2n squared minus n minus 1. So my first thing, a times c. What is a? 2. What is c? Negative 1. So what is a times c? Negative 2. So in my x, I have negative 2 and negative 1. Alright? So what numbers can I multiply to get negative 2, but add to get negative 1? Negative 2 times 1. Everybody see what we did? Fill in your box right now, and then I'll fill in my box and check you. Remember, we don't have an x, we have an n. If you happen to interchange, it's not a big deal, okay? But just remember, a variable this time is an n.
With the x and the n.
Yes. Alright, there's my box. You could have had this box as well. I was a little bit out of my box, sorry. You could have had that one as well. So either box would have worked. Okay? Any questions on the box? Yes. Which one did you do? Okay. I want you to factor right now. So you're doing the next step. I want you to factor your 2 columns and your 2 rows and pull everything out that you see that they share in common. Yes. Now, if they both have a negative, then you can factor out a negative number. Okay? But if one's positive and one negative, you can just pull out a positive. Okay? And then we'll deal with that negative in a minute if only one of them contains that negative. Alright, Jackson, tell me what you factored out of this row. Mm-hmm.
2n
Okay.
plus 1.
Okay. We're not going to worry about plus yet, but we're going to do 1. Okay. Jenna, tell me what you got in your columns. Okay. And 1. Okay. Now, let's look. This was positive, right? So both of these are going to remain positive. This was negative, so this now becomes a the subtract or negative. This was positive, so this is going to be positive, which means that's going to be plus. So I have 2n plus 1 and n minus 1. And which, if you want to, you can FOIL this to check, and you should come up with your answer.
Could you already put like
Where?
negative 2n?
Right here. You could have. Okay. She's asking, what Avery asked me was, because I saw that this was a negative 2 and a negative 1, could I have already factored out a negative 1? Yes. But it's still going to come out looking like that negative 1. Okay? And remember, if you factor out a negative 1, okay, you might want to go ahead and remember that you've changed that. You've already taken care of that negative. Okay? That's the only thing. Don't redo yourself and then force it to be a positive. Okay? Any questions on that? All right. The next thing you got to remember is, if I have something like this, one of the first things you may want to pay attention to is between your coefficients, is there a number that I can factor out of all three things to make that a smaller coefficients? Does everybody agree I can pull out a 5? And if I pull out a 5, what does this become? Okay.
Minus 7.
All right. Now I can go to the box method, and my 5 is just going to be part of my answer down here. Okay? But then I can factor this like I did using the box method. So go through that really quickly, take about a minute and a half. Okay? Make your X, make your box, and tell me what two terms are going to be in down here in the bottom. I'll slide back up because I know some of you didn't have it right down. So you're still using your A times C. Okay? You're still going to use your X to figure out what your two middle terms are. Then you're going to go into your box. I've done my X up on the board. Some of you stuck. Hopefully I'm behind you, so you've at least tried something. Oh, wait. It should be negative 2. I'm sorry. Fill in my Y's. Oops, can't even read mine. I was trying to read. Alright. of you got that? I know some of you may not have been quite finished, but how many was going in that same process? Okay? Now remember, because I factored out that 5 in the beginning, he just gets attached right here to the end. Okay? Any questions on that? Let me have you try one more really quick. Did you have a question?
How'd you get to minus 10?
Okay, remember, okay, once I factored, I should have had a 2y and a 3 and a y and a 2, right? Okay, remember, this block here determines what these two things are, positive or negative. If this is positive, both of those are positive. If this is negative, that forces this to subtract. This one determines that right there. Okay? If this was a positive, that would now be a plus 3. Okay? But he's a negative 3, so that's where that subtract comes in. This was a negative 4, so that's why that's a subtract. Okay? Alright, let's look at this one. Try that. Y'all have a puzzled look on your face. Why? I said y'all look like y'all have a puzzled look on your face. Why?
I can't figure out my X.
Okay, so here's my x. What's going to go in the top? What? No. Negative 15. And what's going to go in the bottom? Okay.
So you put the middle.
So what's the 2 that I can multiply to get negative 15, but add to get 7? Well, if I do 5 and 3, if I add them, I get 8. If I subtract them, I get 2. So I can't use 5 and 3. Is there anything? So what is the word we use when you have something that cannot be factored down any... Now listen out. What is it when you have a number that cannot be factored down any smaller than itself and 1?
Infinitely many.
What? Prime. So you're going to write prime that says this cannot be factored. So is there a time that it's going to happen like that? Yes, there is. Okay? So there are going to be times, and you're going to do little silly stuff like 5 and 3. Okay? Because it does meet the 15 mark, but it does not meet the 7 mark. Okay? And you're mentally going to try and make it fit, but sometimes it just will not fit. Okay? So if they cannot factor down, they are what we call prime. Okay?